project is on basics of the greenhouse climate controller. This is the block diagram of the entire embedded system. In this, we are using 16F873A microcontroller. It has 4K flash memory, and it has memories like EEPROM, and it has three ports, input output ports. Port A has analog to digital converter inbuilt analog to digital converter, and port B has I to C communication ability. It has we have to give an external oscillator up to 0 to 20 megahertz. It has time. This microcontroller has timers, uh, and it will support the serial communication like I to C, universal synchronize, asynchronize, receiver transmitter, and serial peripheral interface. In this block diagram we can see sensors like LM35 is the temperature sensor, and YL69 HL69 is the soil moisture sensor, and LDR is the light dependent resistor which changes its resistance value on basics of the light intensity. These all sensors will give the analog values to make the microcontroller to understand this value. We have to convert these analog values into digital. For that we will use inbuilt analog to digital converter. In this microcontroller we have 10-bit ADC. um, with that for ADC there are some registers which we have to configure first, like analog to digital result high register, analog to digital result low register, analog to digital control register 0, analog to digital control register 1. We have to configure these four registers. For steps for analog to digital converter is, first we have to instalize the ADC by registering using the bits, by changing the bits of the register, and we have to select the analog channel. And next, by making the go done bit high, the analog digital conversion will be start, and after that bit get low, the conversion will be done, and it will stored in analog digital register high and low registers. And with that we will get the digital values, and by comparing this we will get the uh, equivalent voltage of the real world parameters like temperature. uh, to equivalent temperature we will get an equivalent voltage. Outputs, like we will use an LEDs to indicate which output was on. Like we have three outputs here: heater, water sprinkler, and light source. This all works on the AC current, like on 220 volts AC. It is when the heater is on, LED will get uh, power supply 5 volts passed to one ground, and it will power on, and we will use relay switch to on these AC devices, because we cannot make a DC device to control the AC devices, so we will use relay switch. Relay switch will switch on. Relay switch has have normally closed, normally open, common pins. When the relay switch didn't got the power supply, it will connect to the normally closed one, and normally open, it will not connect to the normally open. When the power supply is here, it will come to the normally open pin, and with that logic we can make work. We can switch on the heater, or we can switch off the heater, and remaining parameters are swing. I to C communication is a serial communication. It has serial clock line and serial digital line. It has we're using one, we can use one master and many slaves. We have a separate addresses for each slave. and with that address we will call the slaves. We will give read or write commands to them. Thank you.